Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Qualcomm's acquisition of Arduino. So let's dive deep into it. Now you have to understand, Arduino is a very big deal, as in Italian open source hardware and software company. Now here's the deal. They were not the one who were making the microcontroller. Microcontroller was made by Atmel, but the key part is microcontroller was the big deal in 1970s to 80s, and by 90s every devices started to get it. However, even though microcontroller price was chump change, like few cents, and I'm talking back then, the issue was if you had basically if you're just a student, I want to use a microcontroller, good luck. Like you can buy microcontroller, but buying a dev kit where you can just like, okay, I'm going to put this, and having the software kit, and software kit was ludicrously expensive. Not only computers itself were expensive, these things were guarded like viciously. So good luck, and be mindful, microcontroller runs on a what you will call, let's just say, machine language itself. So it's not like you can look into it and understand what the code is. So unless the company gave it to you, yeah, good luck. And they were fiercely guarded. So the idea was low cost microcontroller with all the hard work pre-done, as in I want to buy Atmel at Mega 816 Pi. Okay, you buy it. Okay, but you need PCB, you need power delivery, all those systems. Okay, so done, sorted. Oscillator, all that done, sorted, go home. But you also need software development kit, as in how the heck do you code this thing? And because again, even if you are writing code here, there is a back layer of like this a compiler that is converting it, and that is the hardest thing, that is the most expensive thing. They did that brunt work, so to say. So, and they made everything open source. This was their first PCB. This was their first, what you call, almost finished like prototype. But that time they were thinking serial using, and then they realized, USB was better. Penalty, they did had to add an extra chip to convert that USB to serial interface. But yeah, I think it was justified. So I started that, and they made everything open source. Not only the core, as in the software hardware was open source, as in not only they can use it with this, they can also work with other things. For example, I bought ESP32. I want to code this. I'm using the same software. Why? Because it's open source. Other people made libraries for other things. It started to grow. Basically, it is no longer limited to only Arduino specific microcontroller. Almost all microcontroller supports this. Why? Because it's in their best interest to like, hey, use the tool that you are most familiar with. So that was done, and they made everything open source. Software grew, and the hardware, as in like this puppy, that was made open source, full open source. Like how the heck we are modeling it, like what are the rules set, all that, and lot of Chinese company cloned it. Now benefit of that is the price dropped dramatically, meaning this thing, it was very low cost when it started, and after Chinese flooding, it was like just buy a few of those and like give it to every school kid. That's how low it became in the price. So this was my first microcontroller. This was my Arduino Micro. This had the ability to work with USB directly. It does not require what you call basically a separate chip to do that serial to USB conversion. That's why I bought that. And this was a project where I wanted to use it as a data logger. It did work. So fundamentally, a lot of people started to use this, specifically students. Students got used to this technological stack, and benefit of that is because of the price, because of the whole ecosystem, corporations started to use this for prototyping. Meaning, like, let's say you are making a washing machine, you need a microcontroller. They're like, why not use this? Like, why sign a giant 10,000 page document of NDA with a TI, or just buy this and use it. And once you are ready with it, either just go with that microcontroller, order it, or you can be like, okay, we need something that matches this. You can ask, like, there are many microcontrollers that are pin compatible, so you can do that also. So Arduino was very successful. Italian company, surprisingly rare. So why it is a big deal? Well, here's the deal. It has self-sustaining open source community. Because here's the deal. Any Tom, Dick, and Harry can make an open source project. Heck, I made it's already there in the GitHub open source project, like USB to CSV. The idea was that this will collect all the data and send it, and I wanted all of that data to be saved in CSV file with date and time in the first line itself. So done. I built it. Now here's the deal. Not that many people use it, so it's not a growing community where like hundreds of people are using it and solving its problem or improving its graphics. I always wanted like how this software has Grafana has a like a zoom in ability in a graphs. I wanted that. I could not get that done. But again, if it was a very big, successful open source community, somebody else would have done that. That did not happen. So this achieved that self-sustaining system. And again, this is the reason why Raspberry Pi is so successful. There were many companies, including Asus, that tried to make their own single board computer. They failed because they could not cultivate open source ecosystem that was self-sustaining. Arduino has that. And you can even say that Arduino is the one that made it for hardware. So it's a very big deal. So students learns it, uses it, and masters it. And when they get a job, they contribute to it or buy it directly. So that created a very simple feedback loop. Heck, the first open source 3D printer, not the printer that was like, 70s and 80s, they had like patent wall and like costing millions of dollars, not that. The first fusion system, I think 2008, RipRap, they were also using Arduino's logic ecosystem or almost copy pasting that theme. So it was a very big deal. The market penetration in this scenario is absolute. Like there is before Arduino and there is after Arduino. Absolute. And at this point in time, everybody was using either hardware stack of it or software stack of it. Even if hardware kind of started to lag behind because you have a lot of competition. You started to have competition with basically single board computer from Raspberry Pi, and Raspberry Pi knew that they need a microcontroller. They started to make their own microcontroller. On top of that, you have expressive hardware, similar time frame, ESP32. But again, software, all of them are using Arduino system most of the time. Again, once you're really expert, like you know your stuff, then you can go into their dedicated environments. But starting, most people start in this sort of thing. So it's a very absolute. And they even had the idea of shields. The idea was you created a PCB. That PCB was designed in such a way that you can mount other PCB to it. And they standardized the design. People went cuckoo with that. Like bonkers amount of things. Somebody was making game controller, somebody was putting SD card data logger circuitry into it, somebody was putting battery system into it. They were going YOLO on it. That turbocharged it. So it's not just one thing, it's a compounding ecosystem. And the most priceless asset of Arduino is not the microcontroller, it's not even the software, it's the ecosystem that like loyal people who are working on it to improve it. And so basically in simplest term, it's a Linux of microcontroller world. That's how big it is. Like bonkersly big. Now, Qualcomm is a big puppy. It's a big semiconductor chip maker. There are only few companies that can even touch modern semiconductor, and power electronics, there are a lot more. But like processing, computing, there are very few. Like there is Samsung, there is Qualcomm, there is, you can say Apple, there is AMD, there is Intel, not that many more. So there are some more, but you get the point. Like there's not that many people. So it's a big puppy in that demand. And they have a really good grasp of SoC, as in system on a chip. Meaning if you want to make your smartphone, either you have Qualcomm or you have something else, or Snapdragon. The brand name is Snapdragon. So that's how good they are. Like they are so good that Apple, they're like, no, we're gonna make their own. The first problem they had, the patents. Like 5G, there was a lot of missile firing between basically Apple and Qualcomm based on the basically 5G modem design and all that. A lot of it. It's like, dude, you can't directly copy paste our design, proprietary designs and all that. So a lot of missile firing. So you can understand that this is a significant company, significant and very experienced and really good. So every companies generally take a gamble for a long term. Basically, some companies gambled on LCD technology, some companies gambled on basically plasma TV. Remember those? Some companies gambled on basically AMOLED or OLED, LG OLED. So that's how companies sometimes place their bet. Either it works out or it makes them bankrupt. So Qualcomm's bet is Edge AI, meaning their idea is that your smart home system does not need to talk to basically, super data center to like have a discussion with it. It does not need to do that. It can be done on site. Now, Qualcomm, does it have enough horsepower to do it? That's the USP of Qualcomm. Qualcomm gets that. Like Qualcomm is like, bro, I got this. Me good. Like you can take the same Sony IMX series sensor. You can give that to Qualcomm. You can give that to any other brand, MediaTek, and the output would be drastically different simply because Qualcomm knows how to do light engine processing on the chip. So they know their stuff. They're we good, we got this. So They got the AI part. However, whenever you're talking something like this, you have to understand no hardware works like that. Whereas like, oh, SoC, it talks with everything. Hell no. For example, even if you are talking about device, it will have a device directly dealing with basically USB interface, a device dealing with power. Power is generally done separately. For example, your laptop, it could have USB-C power delivery. That power delivery would be completely independent IC. Your SoC or like Intel or AMD, that will talk to it. It's like, bro, are you working perfectly? Like, just give me a feed, like a flag. Am I receiving power or not receiving power? But it will not do the handshake, and that's normal. So what they need for edge AI is some way to interact with what we call a real world, as in sensors, motors, relay. Now, can they make it that SoC directly does that? Yes, but it would be like taking that, etching it into the SoC itself. It's like, it can be done. Is just like, why? There are companies who are specialized in that. For example, can they have enough horsepower to run a BLDC motor directly, or like a permanent magnetic transfer? Of course. It's just, why? Like, there are people who are sole job it is to make a silicon IC that's like, I got this. We call them power management ICs. They're like, bro, I got this. This is my job. I know how to drive MOSFET. I can do it better than anyone else, and you do not need a lot of passives or something like that. It's like, just work with that. The idea would be, this will be the brain and that will be the muscle. So this is normal. That's why they want something with microcontroller. Now, here's the deal. It's not about the microcontroller, nor it's about the ability to do so. They can, I'm pretty sure they can pick up the phone and it's like, hey, Texas Instrument, can you find me something? Of course they will get it. Issue is having the Arduino ecosystem to bootstrap, meaning they want to make sure that there is a lot of people using the system. Basically, they want to achieve that self-fulfilling feedback loop of open source. Nothing else matters here. It's just that they want to make sure that enough people use it and there is enough ecosystem, enough health in there that people start to get familiar with it. And that's a very great boost for first product that you are releasing. Like, if you want to start a stack, you can't just like, tada, this does everything. That's not how it works. Like, this is a basic stack that does basic things. Okay, how do you make sure that basic stack goes, like, hit the ground running? Buy some company that is tailor-made for that. So like, they are already done on the high end. They're like, hey, smartphone, we done, we good. Smartwatch, we done, we good. Microcontrollers, okay, buy the best company for that. Tada! So this is the first product, Arduino UNO Q. Now, UNO Q is the basically STM32U585, this puppy. Now, this is also a very powerful microcontroller. I'm like, if I compare this microcontroller to what I have like in Arduino Micro, that is Atmega Mega 32U4, which again almost feels deceptive. I thought it was same thing, like, 32U. It's like, no, it's a completely different thing. It's a 32-bit system. Rather than 8-bit, it's a 32-bit system. I think I have something similar in my 3D printer main board. Again, powerful puppy. If you really want to do something, this is the puppy. This is the one that gets the job done. And they have Dragoning QRB2210. Now, here's the, do not look into it. It's an industrial kind of system. It's not Snapdragon or something. It's a calm puppy. It's like, small puppies. And they have stupid LED matrix 8x13, which is like 104 LEDs. I'm like, why you have 104 LEDs? You can just get AMOLEDs. Like, these are cheap. These are very cheap. These are cheap in India. It would be chump change for them. I can guarantee you it would be cheaper than 104 LEDs. Like, even if the LED is cheap, you have to understand, you have to pick and place it. So I genuinely don't get that LED part. Like, that genuinely is confusing to me. It's like, why? Why? That is genuinely stupid to me. And it does have few RGB, and I'm pretty sure one ARGB LED. Although I'm unable to see it, but it might have that. Like, that is common with basically ESP32. They always have ARGB. ARGB is addressable RGB LED, meaning how you have these decoration LEDs. So basically, you have 5 volt and ground and data signal. Data signal tells you like, bro, glow red, glow blue, whatever have you. It does require a library, but does work effectively. So that is there. It has LPDDR4 2 GB. Now, like, isn't that just few years old, basically Raspberry Pi? Yes and no. Raspberry Pi is like, in terms of RAM and all that, yeah, this is old. But in terms of SoC efficiency, this is a SoC. This is like, bro, it can run circle around basically stack of Raspberry Pis simply because it's from Qualcomm. Qualcomm does have certain advantage. So that is there. EMC is there. Not modern Raspberry Pi, like that way, not modern Raspberry Pi. 16 gigabytes of eMMC is there. On 32 variant is available with a dual band Wi-Fi 5 gigahertz and 2.5 gigahertz with a Bluetooth 5.1. So well beefy stack. Now, one of the most shocking thing to me is that it has a full-fledged USB. And again, it really pisses me off about all the mobile manufacturers. Like, if this cheap SoC has that, like full-fledged basically USB-C port, why the heck mobile phones don't have that? I'm not joking. Like, only Samsung's S series has that. Motorola's few Pro series has that. Some Apple has that. Some, let that be very clear. Like, thankfully, Apple did had the idea of like having display output from long ago, but USB 3 does not exist. Like, unless you are going into Pro Max, or only with a very recent model, as in like 2-3 years ago, kind of. And still, even super expensive Android phones do not have that. And it's like, it's not the SoC. I can guarantee you that it's not the SoCs. They're like, hey, why route some like, 4 extra pairs of data wires and like, power IC and all that? It's like, why? That really hurts me. It's like, this has USB power delivery, as in you do not have to worry about it. Good, awesome, GG. It has data of 5 GPS, as in like 600 megabytes per second read and write can be done. Okay, that is awesome. It has display output, meaning you can basically buy something like this. I bought this one for my Samsung Galaxy S23 Fan Edition. Samsung S series does have this DeX capability. This has that. Not all Android has that. That's an abomination. Like, I can get it like for a cheap phone. Mid-range phones are expensive now. Any phone that is above $1,000, this is under $100. So how the heck that's not a common thing? Like, it's not PCB, it's not the SoC. It's just companies are like, who's gonna give? At least Samsung, I understand. Samsung, like, hey, you want that, buy S series. But what about other companies? So that really shocked me. It's like, really? You're giving this hub capability? Like, tada, and this is Mark 1 product. Imagine what can be like Mark 3 or Mark 4 product. So it's like, that's odd. And it does have high-speed connectors on the back. So basically the front one that you are seeing, that's normal Arduino. The back one, those are high-speed connectors, meaning those are for SoC integration. If you want like HDMI output, high bandwidth camera input, those puppy are for that. And it does have a software bridge to connect between SoC and basically STM microcontroller. So what can we expect in the future? Well, here's the deal. Things can go in random direction. We do not know what will happen in the future. Duh. Worst case scenarios, Arduino can lose its open source route and eventually the community could wither away. That could happen surprisingly quickly. So, because again, other companies are working their ass off. Like, again, Expressive is really putting some serious effort into it, and Raspberry Pi is also putting some effort into it. So this is not the time for Arduino to just like, hey, who cares about open source? Nah, you're not in a good company to do so. And but again, the primary intent from Qualcomm's point of view is that keep the FOSS alive, as in free open source software stack. It's a really good for them, simply because that's the only chance they can have to have enough developer, enough momentum to compete against NVIDIA AI. And be mindful, NVIDIA AI is also working on edge AI. They have the data center sorted. Data center is like, bro, we done, we good, we got $4 trillion, we good, we chill. It's just that, how about the edge AI? They are not that great. However, they have been working, like Nano and all that, they have been working long ago. So how do you overtake that? You need a lot of brain power. How do you get a lot of brain power? Buy it directly. Okay, so open source ecosystem is there, but to make sure that brain power does not leave, they have to make sure that they are catered to. So it is in Qualcomm's best interest to make the open source ethos alive. Again, open source the basically low grade SoCs. Don't open source your like flagship and all that. And again, open source does not even mean how the microcontroller is, some more of PCB and power drivers and all that, like simple stuff. And software, yeah, that would be helpful to actually how the heck you are doing USB-C communication, so you can do display switching from internal to external. That is complex. Again, those sort of like, stack wise and all that, it will make sense. Because again, they need to make sure enough people use this as first choice that over time it starts to become like, oh, why work with NVIDIA? This has it. Like right now, why people left Arduino to go into ESP32? Wi-Fi. They're like, hey, you want to buy Wi-Fi? Espressif did it very early on. And that created a ecosystem. So Arduino was losing ground anyway. So they're like, hey, this has it. Like, so now this can take care of two puppies. They can take care of people who want Wi-Fi and all that. They're like, hey, I got you, fam. People who want a full-fledged computer like Raspberry Pi, hey, I got you, fam. So it's a good partnership for both of them. And you have to understand, does it make sense for Qualcomm to take this sort of risk for open source and all that? Yes. Why? They have to pay a boatload of money to ARM Holding, because of the ARM licensing that they are doing for their SoC core. How SoC is built, that's Qualcomm property. But the ARM logic, the ISA, that is from ARM's holding, so they have to pay them. So Qualcomm is paying RISC-V a boatload of money to develop that instruction set architecture. How do you make sure that your open source architecture works with open source everything? How do you develop it? Well, tada! Right now, there are a lot of options in basically expressive lineouts that gives you RISC-V already. It's there. It's like it's slowly starting to seep into the market. So having that's their upper end. It's like ideally they would not like the idea of paying arm holding. They're like, hey, we should develop our own stuff. How would you develop our own stuff? You have to create a stack that can compete. How can you develop the stack? Have boatload of people working on it willingly with their own intent. Low cost, education specific hardware. It's a really good and smart focus from their point of view. They're taking care of the ESP crowd by having Wi-Fi. They're taking care of Raspberry crowd by having whole SoC. So this is really clever, I would say. So let's see what happens. Again, all could fall apart, but there is potential that it could work out. So this was my presentation on basically what the hell happened with Qualcomm and Arduino's marriage. Let's see how it holds up. So hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.